Classwork 4.3 Inverses. What is a relation? A relation is the set of ordered pairs x, y. What is an inverse to the relation? An inverse is a set of ordered pairs yx. Set of order pair yx. So all you do is just switch the x and the y to find the inverse of a relation. How do you determine if a relation is a function? If you have one x to one y, meaning all the x values are different. How do you determine if a relation from a graph is a function? The vertical line test. So if you run a vertical line and it only crosses once, then it's a function. And a vertical line test is up and down. Okay, and this is for a relation. For the inverse, you run a horizontal line test. So that's going left and right, and if it only crosses once, then it's a function. Okay, example 1. Find the inverse of the relation, determine if the relation is a function, then determine if the inverse is a function. So A, here's the relation. We'll just copy the problem. 2, 4, 0, 0, negative 2, 4. Okay, to find the inverse, all you do is switch the x and y. So here's the inverse. 4, 2, 0, 0, 4, negative 2. Alright, so let's see if the relation is a function. 2, 0, and negative 2, they're all different, so this is a function, the relation. The inverse, 4, 0, 4, the 4's are the same, so this is not a function. B. Here's the relation. Just going to copy the problem. 3, 4, 1, 2, 2, 4. The inverse is just switching the x and the y. So 4, 3, 2, 1, 4, 2. Now the relation 3, the x values are 3, 1, and 2. They're all different, so this is a function because they're going to different places. The inverse right here, it's 4, 2, and 4. The 4's are the same, so this is not a function. Alright, moving on. Example 2. Now we're going to find the inverse from a function. So I'm going to copy example A. F of x equals 4x plus 6. Now you remember f of x just means y, so another way to write this is y equals 4x plus 6. Now to find the inverses, I need to switch the x and the y. So now this y becomes x equals 4y plus 6, and solve for y. So here's the letter I'm solving for y. Subtract 6 on both sides. So I have x minus 6 equals 4y. Divide by 4. So now this becomes y equals x over 4 minus 3 over 2. Because 6 and 4 you can reduce by 2. So that's my inverse. I'm just going to write it in inverse notation. F of negative 1. The inverse of f of x is equal to x over 4 minus 3 over 2. And that's our answer. Part B. Find the inverse of f of x equals 2 over 5x minus 1. Remember, f of x just means y, so y equals 2 over 5x minus 1. To find the inverse, just switch the x and the y. X equals 2 over 5 y minus 1, and solve for y. So add 1 on both sides. So this is going to be x plus 1, because they don't combine, 2 over 5y. Multiply by 5 to get rid of the fraction. 2y equals 5x plus 5. Divide everything by 2. Y equals, you can't reduce, so 5 over 2x plus 5 over 2. Okay, I just have to write it in inverse notation. The inverse of f of x is equal to 5 over 2x plus 5 over 2. And that's our answer. Okay, and last one for example 2c. We're going to write f of x is equal to 3x squared plus 5. F of x just means y, so I'm going to write y equals 3x squared plus 5. To find the inverse, switch the x and y. So this is going to be x equals 3y squared plus 5. After I switch the x and y, since it's a function, I need to solve for y. So here's my y. To get rid of plus 5, you subtract 5. Can't combine x minus 5, so write it separately. To get rid of multiplication, divide by 3. So you have y squared equals x over 3 minus 5 over 3. And to get rid of the square root both sides. So y equals plus or minus square root of x over 3 minus 5 over 3. Now I'm almost done with this problem. I just have to write it in the function notation. So f, the inverse of f of x, is equal to plus or minus square root of x over 3 minus 5 over 3. And that's your answer. Okay, going to example 3. Determine if the relation is a function, then determine if the inverse is a function. So you remember, to check from a graph for the relation, we have a vertical line test for the relation. And to check the inverse, we have a horizontal line test. So I'm going to start with the relation right here. I run one line across, and just check to see if it only crosses one point on this vertical line. If it does, it's a function. So it only crosses once here, everywhere here. So yes, this is a function. Inverse. Inverse is the other way. So I just need to run this horizontal line from left to right. And if it only crosses one point, then it's a function. So yes, this one's a function. So B, relation. Let's see. Right here, the relation is not a function because straight up and down, it crosses at 2 points. Okay? And you can't be at two places at once. That means there's two x's going to the same y value. So this is not a function. The inverse, if you run it straight down, it only crosses at 1 point, so this is a function. C. I run my line straight up and down, and it only crosses once, so it's a function. The inverse, I run my function straight left to right, and it crosses at 2 points, so it's not a function. And last one, D. I run my vertical line test straight up and down, and it only crosses at 1 point, so it's a function. And the inverse, the horizontal line test is left and right. I run it straight left and right, and it's a function. Thank you for your time. This is classwork 4.3, Inverses.